The diagram shows an arc of a circle. The width of the arc is 8 centimeters and its height is 2 centimeters. Find the radius of the circle from which the arc is taken and find the length of the arc. So what we're going to do is draw a line from the starting point of the arc to the end. So draw a line straight across. And we're also going to go to the center of our arc and drop a perpendicular straight down. And we stop at where the center of the circle would be. So this would be the center of the circle. And we join that point to the start and to the end of the arc. And what we've done is we have created on the bottom two right angle triangles, and they are congruent, so they're equal, completely identical. So if from the starting point of the arc going straight across to the end point of the arc is 8 centimeters, then from here to here must be 4 centimeters, and from here to here must be 4 centimeters as well. And that's because this perpendicular cut that line in half, it bisected it. We know that from here to here is 2 centimeters, and we know that from here to here is the radius. Likewise, this is the radius. So then from here to here must also be the radius. So from here to here must be the radius minus 2, because we're taking off the 2 units at the top. So we're going to use this right angle triangle, and we're going to use Pythagoras' theorem to find r, which is the radius. So we label our triangle ABC, where C is the longest side, so r is C. So r minus 2 is A, and B is 4. We sub into Pythagoras' theorem, C squared equals A squared plus B squared. So we get r squared equals r minus 2 to be squared plus 4 squared. R minus 2 to be squared is r squared minus 4r plus 4, and 4 squared is 16. The r squareds will cancel off on both sides. We bring the minus 4r over the equal sign, it becomes 4r. 4 plus 16 is 20. 20 divided by 4 is 5. So the radius is 5 units, or 5 centimeters. So I've drawn it out again over here, and this time labeling the r as 5. So we were asked to find the radius of the circle from which the arc is taken, which we have. The radius is 5 centimeters. And now we want to find the length of the arc. So in order to do that, we need to know what the angle is at the center. So we need to know what this full angle is, but if we find out this angle here, this angle alpha, coloured in yellow, well, since these two triangles are identical, they're congruent, then we just multiply this by 2 to get the full angle. And then we can use that to find the length of the arc. So we need to figure out this angle. So remember that this is a right angle triangle, and we have the opposite side being a length of 4 centimeters, and the hypotenuse, which happens to be the radius, being 5, and we work that out over here. So since we have the O and the H, and we're looking for this angle, from SOHCAHTOA, we're going to use SO, which states that sine x, or sine alpha, is equal to the opposite over the hypotenuse. So the opposite is 4, the hypotenuse is 5, and since we don't know the angle, we use sine inverse. So sine inverse 4 over 5 is 53.13 degrees. So that angle there is 53.13 degrees, and doubling that gives us 106.26 degrees. So this full angle is 106.26 degrees. So the length of the arc will be 2 pi r multiplied by 106.26 over 360 degrees. So this formula is in your formula book. We're going to let pi be 3.14, the radius be 5, so remember we got that up here, the radius was 5, and we get 2 times 3.14 times 5 multiplied by 106.26 all over 360, and that gives us 9.27 centimeters. Now we didn't have to let pi be 3.14, we could have left it as pi and just pressed SD at the end to get a decimal close to this. So 9.27 centimeters. And that is the length of our arc. B. The cross section of a piece of corrugated plastic used for roofing consists of a series of circular arcs, each 8 centimeters wide and 2 centimeters high. So 8 centimeters wide, 2 centimeters high. So basically the arc that we were using in part A. A sheet of plastic is 1.6 meters wide. If the sheet could be flattened, how wide would it then be? So from part 1, we know that the length of the arc is 9.27 centimeters. So in the sheet of corrugated plastic, the number of arcs will be 160 divided by 8, which is 20. So the 160 comes from the 1.6 meters, which is 160 centimeters. And that's divided by 8 because this distance is 8 centimeters. So the width of the flattened sheet will be 20 multiplied by 9.27 centimeters. So 20 multiplied by 9.27 centimeters, which gives us 185.4 centimeters. And if you want to change it into meters, just divide by 100 to get 1.845 meters. So the sheet of plastic, if it was flattened, it would be 1.854 meters.